hacking Lucene and Solr for fun and profit. And I want to first start off, I mean, the word hacking to me obviously has a lot of different connotations, probably to you too. What this means in my context is, what are all the things that I like to work on and talk about and think about and write about? So this talk is essentially a mishmash, if you will, of a number of different topics, which probably in their own right could be sessions on their own, but I just want to kind of cram them all and basically give you food for thought, things to think about, ways to use Lucene and Solr perhaps in interesting ways that you hadn't done before. So my first kind of tenet around this is, you know, Lucene and Solr, et cetera, have made keyword search a commodity. It's very yesterday, if you will, to just be doing keyword search. So I want you to think about search as being a system building block, right? Chances are, if you're here, you probably have a computer science degree, right? Nod. How many people here have a computer science degree, right? What are the two main classes you took in computer science that was rammed home to you every day? Data structures and algorithms. You're a computer scientist. Use the right data structure, use the right algorithm. I would put forth that search has some really interesting data structures and really interesting algorithms, and that if you use those things in interesting ways beyond just doing free text search, you can solve some other problems that maybe you hadn't thought about. So that's a lot of what this talk is about. So essentially it's, if you embrace it, if you like those data structures and algorithms, use them in your other applications. The other thing I think that comes with this notion of leveraging these structures, et cetera, is that you also need to embrace fuzziness. You need to embrace probabilities. Now, this is all the rage, of course, these days with big data and machine learning, et cetera. If you think about search, that's essentially what you're doing. There's always this notion of fuzziness involved in what you're doing. You're essentially ranking things, right? So when we rank things, we're essentially saying, here's what we think is important. But that notion of importance is really up to you as the application developer. And so I want you to keep that in mind as we go here as well. And then last but not least, I think anybody who's been paying attention or doing search in recent memory, you start to realize that doing that actual TF, IDF, length normalization stuff that, you know, guys like me stand up there in training classes, et cetera, and tell you all about, that's just a handful of the features you really care about in your actual application, right? So things like time and retweets and ratings and reviews and all of these things are also scoring features. And in fact, I guarantee you when you go back home and you look at your actual application, you're going to realize that the actual core keyword matching stuff that Lucene is so good at is just one small part of the scoring that you do in your application, right? And is one small part of what matters to your users. And so by expanding your mind to think about those kinds of other scoring features, you can then think about how can I properly leverage them in my search engine such that my whole application gets to be a lot more efficient. With that, digging down one layer and saying, okay, well, what is Lucene and Solr really good at? I'm not gonna stand up here and try to tell you that I can cover everything underneath the sun, but I do think there's at least three kinds of things that you can boil it down to, and there's probably more, but you know, for the length of time and the purpose of this talk, I'm gonna focus in on these few here. Obviously, you know, out of the box, we can do good keyword matching and fuzzy text matching, if you will. We can deal with the ambiguity of language or languages, and we can do a lot of fun stuff with that. And I'm going to cover a few hacks around those things. It's also really good, I think, at doing essentially non-traditional data quality and analysis. So this isn't your typical BI type application where you're doing a bunch of joins in a database and then visualizing it. But, you know, when you start to put together things like faceting and the stats component and suggestions and spell checking and analysis of missing fields with spatial information, you all of a sudden start to have this ball of, you know, this bunch of things that you can start to combine together in interesting ways. And so I like to think about those. Last but not least, we're really good again at this notion of ranking, what I like to call top N problems, N being some value there. N can be 1. What do we call a top 1 problem these days? It's a key value store. What do you call top 10? Well, that's search, et cetera, right? So there's a lot of different problems that can be modeled as top N problems, and so we'll cover some of that as well. So with that kind of pretense out of the way, this notion of hopefully setting your mind on thinking differently around search or thinking about how I can leverage search. I'm going to break the rest of this talk down into 3 main areas. First, we're going to talk about, I think, just some classic search things that you could just go and do at home, look at Lucene underneath the covers or look at Solr under the covers and think about how to implement that as a straightforward search problem. Second, I do have a math degree, although I don't ever claim to be a mathematician. For the sake of this talk, trust me, I'm a mathematician. Hopefully this will prove interesting to you as well. And then last but not least, I wish I had thought of that. So covering a topic that I find particularly interesting because it uses some of the new capabilities in Lucene and Solr in ways that I hadn't thought of, but other people in the community have. So I'm going to co-opt it a little bit and extend it with hopefully another interesting area that you'll also find useful. So let's start off with the search hacks. First off, I have a little bit of an academic background. I love to think about the core functionality of how search works. If you haven't been paying attention to Lucene and Solr 4, especially Lucene 4, you know that there's a lot more flexibility in Lucene these days. So we've made it a lot easier for you to plug in things. And I think the 2 main things that get me interested and excited about what you can plug into Lucene is the first one being codecs. Essentially how things get encoded into Lucene when you're storing, posting lists and all that stuff. So all that stuff that Michael Bush was talking about this morning around how they do all these manipulations, you can plug in your own stuff there as well, and it's pretty straightforward to do. And in fact, these, 5 lines of code or so from an example I'll show you here that's available as code from this link, show you how to do what what is referred to as the simple text codec. And just like the name sounds, what it is doing is the entire Lucene index is stored in simple text. So what does that look like? Actually, I've got it open here in my text editor. This is, for instance, and I know you can't fully read it, but for effect, you can see, for instance, this is the stored documents in Lucene in plain text. Document number 3 has 2 fields. Field 0 is named ID, it has a string, and it has this value of ID 3, right? Great, I've got a simple text index. What good does that do me? Well, not a whole lot. You're not going to do this in production, of course. The cool thing I think about this from the Lucene standpoint is this passes all of the Lucene test framework, right? You could plug in simple text codecs into the Lucene test framework, and the whole thing would pass. It would be really, really slow, but it passes. The other thing I think about in terms of putting my academic hat on is this is a great way to understand how search works, because here's the stored fields. Oh, by the way, I've got other of those files open up. This is, I think, like the high-level metadata around the index, tells you what version is Lucene and all of that. And here I've got, remember Michael was talking about posting lists earlier? This is the posting list in text, right? So it's a great way to learn. All the rest of the stuff that Lucene does underneath the hood that makes it really fast is essentially optimizations off of this stuff, doing all that delta compression or variety of compression techniques, etc., right? So that's codecs. The other one I mentioned, so codecs is essentially at that indexing side, storage side, all of that kind of fun stuff. The other one that's interesting when you start to think about relevance is this notion of similarity. I mentioned there's all these scoring features out there and available to you. There's actually a lot of different ways in Lucene and Solr that you can implement relevance. One of the newer ways actually is to implement your own similarity if you want. Now, why would you want to do that? Maybe you're up on the academic space, you like to keep up on the latest and greatest things, maybe you're a researcher. One of the things you can do, for instance, is go plug in what's called BM25 scoring. BM25 scoring essentially adds a few more features into the way documents are scored, and the academics will tell you that it performs way better than Lucene's. And in fact, up until Lucene 4, the academics always knocked Lucene for saying, oh, well, you guys don't support BM25, therefore we don't take you seriously. Well, now not only do we support BM25, but I think there's like 8 or 9 different models in there. More importantly is it's actually a well-defined way that you can plug in your own similarity there. So if you want to go hack at that level, you can do that. So for instance, using this same code that's available here, I've got a little bit of code that runs tries out different similarity factors. And in fact, you can see here, I've just done some simple queries, one using Lucene's default scoring and one using BM25. And voila, they produce different numbers. Yay, I've got different scores, right? So they do indeed work. Would you ever want to use them? Standard caveat, consulting answer, it depends. What you should do, of course, is have a relevance testing framework available to you. I hear there's some talks here at this conference on how to do that. Then you can make a judgment call as to whether that version of similarity is better than what Lucene provides by default. But if you just want to understand how this stuff works, if you want to learn information retrieval at a deep level, these are two cool places to go figure out this kind of stuff, and I would encourage you to check that out. So that's search hack number one. Next one is actually building out a question answering system. This is relatively straightforward to do on search. This is something from shameless self-plug for my book that we do in Taming Text to show people how to tie together a number of different concepts. So I've got a screen grab here, but I'm actually going to switch over to Safari. I've got a live working system. This code is all publicly available. I can come in here and, in true demo fashion, ask a pre-canned question like, what is trimethylbenzene? Which I know you guys were dying to know about, right? Well, you can see here I've actually built a really lightweight QA system. This is not something you would put into production. It's a book demo, right? But you can see here I actually got back a pretty good answer. It says trimethylbenzene is a colorless liquid with chemical formula CH. And then you can see actually underneath the hood, here's the passage, i.e. the Solr document that was retrieved from. And I did a bunch of stuff on top of the values you got from the search engine to then go and decide how to answer that question. In fact, if you look at the IBM Watson paper, they use Lucene for passage retrieval, i.e. for getting this full document. And then they do a bunch of stuff on top of it, similar to what I did. Obviously, what I'm doing is a lot lighter weight, to then extract the actual answer, right? And especially if you're in a specific kind of domain, i.e. you're not doing web search, maybe you work at a chemical company, you can actually get pretty good results with a fair amount of work, or not a lot of work, I guess I should say. If you want really great results, of course, that's, you know, a whole more undertaking from that. But you can see it can answer other kind of questions, like if I ask who is 10-minute warning, there it's a punk band from Seattle, Washington. Again, in true demo fashion, I, of course, know what good questions there are to ask. But this also highlights a number of other things that you see in search, which is this system is only ever going to be as good as the content underneath as the data store. So what I'm doing here is using Wikipedia as the source of truth. Your question answering system, just like your search system, is never going to give you answers for things that it doesn't have in its engine. Okay? So if we dig in a little bit more, what does this look like as a really simple QA system that you can build on top of search? And in fact, all of the tools are available to you in open source. First, we've got to get that content in, that truth, into the system. Pretty straightforward analysis pipeline kind of going on here. I've got to break down my documents. In the case of QA, you're usually breaking them down into sentences. Some people will do it as paragraphs. Some people will do it as individual words. I typically start with sentences. And in my particular case, all we're doing is looking for facts. And in fact, we're looking for only certain kinds of facts of particular things of named entities, like people, organizations, locations. But you could, in a sense, plug in other features or other extraction capabilities here. And then we're going to go and use those facts as part of the indexing process to store them into the Lucene index in an interesting way. And then at query time, we get a natural language question in, what is trimethylbenzene, right? And we've got to do some magic on top of that, like we call it, what's known in the QA space as determining the answer type. What is this question asking for? Is it asking for a person? Is it asking for an organization, et cetera, right? Because now I think you just had a light bulb moment, right? This correlates with that, right? So I've indexed interesting things over here, like people, places, organizations, right? Now I know what kind of thing I'm looking for. How do I then generate a query that will allow me to match those things such that I can get back those initial passages and then I can make a scoring judgment on those passages and return back what I think are good candidates. So that's Watson in a nutshell right there. If you go read the Watson paper, this is what it's doing. you know, they've got a whole lot more magic than I do here. They've got a whole lot more magic than I do here. And of course, they're doing this at massive scale across, you know, hundreds or thousands of data sources, right? Whereas I'm just using Wikipedia, right? And they have an whole arbitration system for determining which data source is the authoritative one or is the right one, right? So, digging in a little deeper, a couple of the things that you start to realize you have to do. Code here for doing sentences. This is a little trick. Most of the time when you're doing analysis in Lucene, you're just looking at a single token. Well, you've got to do some buffering here. You've got to have some smarts around looking at looking for sentences, etc. So you've got to do some buffering there. In my particular case, I'm using OpenNLP. There's actually a patch available to Solr right now for integrating OpenNLP. Lucid, as a commercial plug, we also have some named entity work. I know there's other people here who do that as well. And then essentially, we're treating these named entities or the entity types. Is this a person? Is this an organization, etc., as what you could essentially think of as a synonym or as a payload that is then associated with a particular set of tokens in the index, right? And here's where you can find the code for that. I won't go into details on the code for that right at the moment. On the search side, what we've built out is a custom query parser that essentially uses a classifier to say, what is this thing looking for? What kind of answer type is this? This is essentially, in Solr parlance, a Q parser, right? And the Q parser plugin, that question comes in. We do a classification of it. We say, this thing is looking for an organization. We then use span queries, which allow you to not only find which document matches, but where in the document does it match. And then we return back those passages. And then afterwards, we then go and rank those. Digging in a little deeper on that, this just kind of gives you a little bit more idea around what's involved with the answer types. So like I said, I think in our example, we use people, location, organizations, time, and maybe a few others. If you look at OpenNLP, it supports, I don't know, like 30 or 40 different types there. And in fact, you can plug in your own as well. And then one of the other things you have to do is train the classifier to recognize the questions. And what this one particularly does is there's a bunch of seed questions or a bunch of training examples. For this case, it says, which French monarch reinstated the divine right of the monarchy to France? And so that very first letter there, a P, well, that's a person. So that's saying that this question is looking for a person, and then underneath the hood, the OpenNLP stuff is figuring out which features are associated with person, and then as you train the system, it gets better over time, and you can figure out what these answers are, right? Any questions so far? All right, very cool. Trust me, I'm a mathematician, all right? So don't ask me any real math questions, though, because I get to wave my hands at those. So you already heard me talk about classification just in training an OpenNLP classifier, but as it turns out, you can build classifiers into your search engine as well. And I'll cover a couple of different ways of doing that. What's a classifier? A classifier's job essentially is to put a label onto something based off of the historical view of what it's seen in the past. So in the book, we do an example of classifying Stack Overflow documents and putting tags on them, like saying, you know, this particular document is about Java, it's about Hibernate or Spring or whatever. In this case, I guess it's about Java, but you can see also there's other related tags. Show how you can do this using a couple of different approaches in the book. Two of them are Lucene-based, and one of them is Mahout, and one or two of them are Mahout-based if you like to follow that project, which of course I do. So that's classification in general. Lots of use cases for classification these days. And so you can build a pretty quick and dirty one in Lucene. And what we lay out is actually two different approaches. The first one is what's called Knearest Neighbors, and then the second one is just a simple TF-IDF one. So I guess I could have put this one in into the search hacks one too, but I put it here for the sake of tying it into the math, because essentially what's happening underneath the hood is you're using the fact that Lucene's really good at vector space calculations and recognizing that many classification problems can also be seen as vector space calculations. Therefore, I've got a really fast vector space machine. Why don't I ask questions of it on how to classify, all right? So what's the difference then between the KNN one and the TF-IDF one? Both of these, by the way, are only going to give you, they're going to give you good but not great performance. So you'll probably find that other classifiers like support vector machines or logistic regression, etc., will give you much better performance, but they also usually take a lot more work to do, and you usually already have your content into search because that's just usually a given part of your application. So the way KNN works, K nearest neighbors, the hint is right there in the title. The letter K is how many things do you want to look at? So I might look at the 5 closest nearest neighbors. So what that's doing is I've got this document in the middle here that is the thing that I'm trying to classify. And the way I do that is I look at who are the 5 nearest neighbors to me. In this case, there's 2 that are labeled C, because all of these documents in my system have also been labeled with their existing labels, like in this case A or C or D or B. And so then I'm basically looking at which documents get retrieved and how many of them have which labels. So in this case, there's 2 C's, there's 1 A, there's 1 B, and there's 1 D. So the KNN approach, a simple way of doing it would say this thing should be categorized with the letter C. Does that make sense? You could, of course, do variations on this too and see, you know, if there's ties or if there's a bunch of different answers here, you could do that, right? Quick and dirty actually works pretty well. Not going to be great, not going to be best in class. You're not going to win best paper at an academic conference. But you're going to find out that it does pretty good. The TF-IDF one is essentially a slightly different kind of retrieval problem in that what I do here is I take all of the documents that are labeled with A, and I concatenate them together into one document. So it says this one document has all of the features of all the documents with this same label, right? And then it just becomes a straightforward retrieval problem of, you know, get me back, take my document in, get me back the ones that match based off of the full TF-IDF ranking, and the top one is my label. So in this case, I think it labels out as D. It was, according to the example, that's the closest one, even though the picture, I think, looks a little fuzzy there. Well, it's closest to this big circle as opposed to being closest to some of the individual ones. Okay? So that's TF-IDF classification. There's trade-offs between these 2 different ones in terms of how you index your content and all of that. But essentially, it's just a search retrieval problem. Recently, and I haven't checked this one out in depth, so this is homework for all of you in the audience. There is actually now a native classification module in Lucene that implements a few different classifiers. It basically builds and trains off of the index by itself, as opposed to the stuff I'm doing, where, you know, I'm basically playing tricks with the search side of the equation. Here, it actually works off of Lucene, and you can hook it in. It supports naive Bayes classifier, which is a pretty straightforward classifier, works pretty well in most situations, but isn't, again, the greatest. There's also another KNN one in there, and then there's a perceptron one, perceptron being a lightweight neural network type classifier. So that's in the, I think it's under the Lucene modules and just called classifier in that package there, in the classification package. Like I said, I haven't tried that one out myself. But if you're interested, it is there as of, I think, like 4.2 or 4.3, maybe somewhere in there. The next one I think is another pretty interesting one, and I believe there's at least 1 or 2 other talks, full-length talks on this one at Revolution, and there's been some in the past before. I know Trey Granger from Career Builders talked about this in the past. Myself and Ted Dunning have in the past as well. And this is essentially building a recommendation engine out of search. Now, why would you want to do that? You could go get Mahout, and Mahout is really good at doing collaborative filtering-based recommendations, i.e. those kinds of recommendations of people who bought this also bought that, right? And it can scale out to really large numbers, etc. and it's Hadoop based and has all of the Hadoop overhead to go with it. But it turns out you can often take that Mahout stuff and feed it into your search engine as well. And so now you have some really interesting capabilities, right? You can do collaborative filtering based scoring out of your Lucene index. You can then combine that with contextual information, i.e. keyword matches or category matches or other kinds of things. So now I've gone beyond what Mahout can do, because Mahout only does people who bought this, bought that. It doesn't do things like, hey, people who are items like this based off of their actual features are also like these other kinds of features, right? And that's a classic kind of search problem. So now I can start to combine those things that say, oh, I've got good keyword matches here or content-based matches, and I've also got the collaborative filtering votes that say this document should be ranked higher, right? And oh, by the way, Lucene and Solr have some really awesome spatial capabilities these days, right? So what's the ultimate kind of recommender that you would want to give your users? Give me all of the documents, or give me all the best recommendations based on where I'm located right now, right? What is the best restaurant based not only off of my social network, but based off of the type of foods I like and happens to be near where I'm at, and as you'll see in the next hack, also is open at this point in time, right? So now I can start to answer all of these questions out of the search engine, right? I used to have to go to the database and PostGIS and Mahout, etc. It's all in the index, and it all fits really well into the math that Lucene and Solr and the capabilities that Lucene and Solr are already offering you. If you want more details, Ted calls this multimodal recommendation. I think there's a number of other variations on that as well. If you look at the RecSys conference, which is the big academic conference on recommendations, I believe this past year there was a good paper in there on using search and recommendations together as well. So, and there's also a GitHub project from Pat Farrell is his name. He's in the Mahout and Solr communities, who's brought this Mahout stuff together with Solr. So basically have Mahout produce the collaborative filtering matrix and then store that into the Solr index so that you can overlay these other things on top of it. What are some of the basics here behind recommendations in case you haven't done it? We've got users and things. Sometimes we've got preferences as well. So that's your basic matrix as it starts out. The way this works at a deeper level then is I want to start to look at the history of people browsing through my content as they've been a part of this. So in this particular case, I've got a matrix that shows these 4 items and these 3 users. And if you do some counting here, you can see that item 1 and item 3 co-occur together twice. They occur together once here as user 1 and once here as user 2. So they co-occur together 2 times. That becomes important because what I want to then do to hook this into my search engine is I want to start to calculate more interesting things, like what are the co-occurrences between items, right? How often does T1 occur with T3 or T4, right? So that's important. And then I want to start to look at what is called the log likelihood calculation. This is something that Ted Dunning is sometimes called the Dunning statistic. So it starts to look at essentially how are the various different variations of these things co-occurring with each other, without each other, etc. And from that information, I can then go calculate some scores that I can then put onto the documents themselves. And I'm just going to refer you to the details at this talk last year that Ted and I gave together, or this spring, I guess it was, at Lucene Revolution that shows how to do the rest of this stuff so that you can go and dig in on your own, right? So that's kind of the gist of doing co-occurrence stuff into Solr itself or into Lucene itself, and I think it provides for a pretty powerful kind of recommendation engine. So my last hack, any questions on recommendations, by the way, or any of those other ones? All right, cool. The last one is, gee, I wish I had thought of that. I promised in my tweet leading up to this talk I would talk about the time-space continuum. As we all know, these things are intimately linked, right? So we should have this as part of search. This one was a bit of a head-scratcher for me at first, and then I saw a really good talk in an email thread between Chris Hofstetter, David Smiley, and a few other people in the community. So I thought, gee, I'll co-opt that into my talk. And the interesting idea behind it is, if you haven't looked at Lucene 4 or Solr 4, there's some really cool new spatial capabilities that come from a project called Spatial 4J. Spatial 4J is essentially a shim layer that allows you to plug in true spatial libraries. In this particular case, the father or mother or whatever you want to call it of spatial capabilities in Java is a library called JTS, the Java Topology Suite. Okay? The reason why we have all this shim layer stuff is because the license for it is not compatible with the Apache license. Otherwise, it would have been packaged in there in a heartbeat. So unfortunately, due to politics and legal reasons, it's not packaged in, but it's easy enough to install. You can go get JTS, you drop it into the Solr package or into the Lucene package, and it should just work, okay? And the interesting thing that you can start to do with these things that this talk from Haas lays out and is kind of demonstrated here is that you can use these spatial capabilities to solve non-spatial problems, okay? So for instance, in the pre-spatial capabilities, it was really hard to ask questions of the search engine like, what restaurants are open right now? Or in this particular case, Haas is asking the question, which shifts? You've got a bunch of workers, they each work shifts. Which workers are working together at the same shift, right? Do they overlap, do they not overlap, et cetera, et cetera. It turns out that that whole problem, which was really hard before in Lucene 3 and Solr 3, et cetera, before, companies like Yelp, et cetera, who live this every day, they had to customize all of that. That becomes really simple using the spatial capability because what you're going to do is actually just map all of that information into, guess what, an n-dimensional space, or in this case, a two-dimensional space. It's just graphing in 2D here. This is the shift start, and this is the shift end. And so you can see for like Bob here, Bob started at, let's see, that's 2 and ended at 4, and then Bob also started, his next shift was at, 6 and 9, and then so on up the chain, right? And so then, in order for me to figure out whether these people are in a particular shift or who overlaps with what, I can just ask this question here of, do these points in space intersect, in this particular case, with this rectangle, right? And now all of a sudden I get back all of my answers, voila, piece of cake, right? Now it turns out that one of the cool things about all this spatial stuff is you actually can give arbitrary polygons here. You can also even go beyond this and look at polygon intersections using the Java Topology Suite. I'm also told that coming in one of these updates of Spatial 4J is that you'll actually be able to draw paths in space and look for documents that are within some epsilon of that path. So if you think about route finding, find me all the restaurants on my way from Dublin to Galway, right? Find me all the gas stations. Pretty cool, right? You can do that route finding stuff on there. And of course, like I said, this Java Topology Suite, it's not the Java Geospatial Suite. So this works in n dimensions, which is really powerful, right? So for instance, another example of this is, let's take a look at finance. What if I was really interested in what companies are trending, right? Or what's happening in real time or near real time around financial ticker information? And this is merely a thought experiment at this point, with credit to Chris Hostetter as well, who helped me walk through this earlier today. What if I was able to take in 2 dimensions, on the x dimension time, and on the y dimension, the percentage change of that stock between the time it opened and the time it closed, right? So that I could then index that delta, essentially, right? And so you could see, for instance, you know, at this particular time, Microsoft was up, but then later in the day, it was down. Apple was up, Microsoft was up, you know, IBM up, down, et cetera, right? Now you can start to ask questions like, who is up from 3 o'clock till now, right? Or in the last half hour, who was up or who was down? Or you could even start to, with that line drawing stuff, I think you could start to look at perhaps trends that are going on. This is just a simple bounding box intersection going on there, right? The key, of course, is doing the indexing tricks to make sure that I can deal with that kind of stuff. But I think there's a lot of interesting kinds of questions you could ask of that kind of data. I also think you could probably even make this work just off of the raw content itself. Perhaps if you could do some tricks at the lower level here. I haven't quite worked through all of those, but instead of having to calculate percentage change? Could you just look at the raw ticker and do some aggregations as you're looking at content that matches? You could also, again, just like with the recommendation stuff, start to overlay that contextual thing that search is really good at too, right? Find me all of the stocks in the technology field who are trending upwards in the last 15 minutes, right? Or find me all the stocks that aren't Apple that went downwards when Apple went upwards, right? Can you ask those kinds of questions as well, right? So that would be a bounding box down here, filtered out to have Apple not in it, etc. Or you'd do a query to find when Apple is going up and when the others are going down, those kinds of things. So you can start to see how you can mix and match all of those things together. So with that, I'll leave you with a bunch of resources, and I'm happy to take some questions. Or maybe I should ask some questions of what hacks you guys have done.
A lot.
A lot? Like what?
We build visual image search. We extract information from the pixel data and store them in a binary kind of fashion in the index, and then.
So this guy puts visual image information into the index as well. It's a great use case, I think. That's really interesting. Actually putting the raw image content in as a vector, if you will, as a document, and being able to do matches off of that. So presumably you have some query language that maps shapes and things like that into the index.
And not exactly a kind of, yeah. But it's a very academical approach, because we extract all the information from the pixel data. The index only gets 55 features that represent the position where we then can do nearby searches to get the visual.
Cool.
And yeah, we do some textual stuff to improve that information. What is the contextual information in that image, and then we combine it to one score, and yeah, that's it.
Perfect. So if anybody needs image search, go talk to this guy, right? All right. Any other questions? Or I don't even know what time. I don't have a time monitor up here, so I'm not sure what our time is at. Any other questions? Cool. Well, hopefully leave you with some things to think about, some ideas to try out, in particular some, especially the spatial stuff to go try out, because I think that's probably the most fun out of all of this. Yeah. So the question was, has anybody tried to do graph type things? So like as a lightweight Neo4j type graph replacement. I do know of some people who are doing that. There has been some talk on the dev mailing list around, could you do graph stuff in Lucene itself? Solr, of course, adds so that caching stuff and all that on top, but like in core Lucene, I think this particular person came to the conclusion that it doesn't do very well because it's hard to update the links. But now that there's been some updates around, and I think we kind of at least have a strategy and some initial work on doing updatable fields in Lucene, that once that comes along, that you'll be able to do it. And in fact, I know of a very large, I don't even want to say their name, a very large company that's doing this, who deals with a lot of social graph information, that is not doing the full graph, but the first two hops in Lucene. And for them, that turns out to be the most important, those are the most important features for them. And so they're able to deal with those effectively in Lucene, and then put their layer on top. And they've actually indicated they will be donating that back. So that may be coming, but I can't promise that. So
Would be great for recommendations.
the point was you could do recommendations off of graphs as well. It's another way of thinking about it. Another interesting one, at the end of the day, under this notion of mathematics, right, if you really think about it, search is a vector times a matrix. Right, and so when you start to see problems as vector times sparse matrix multiplication, then all of a sudden a lot of other problems kind of open up to you. You could also look at graphs as essentially a matrix in many ways with attributes attached to the cells. So there's a lot of different ways to represent this stuff, and I think that's one of the key takeaways. So you may find in particular that you have your search engine already up and running. You know how to deploy Solr. It's easy to deploy Solr. Go and then apply these other techniques to it. Even though sometimes it doesn't feel at first like it's a good fit, chances are it can be. All right, thank you very much.